Okay, let's continue from the yesterday's where we have left. Yesterday we had talked about the disturbances. Disturbances, I have already told you. Disturbances are of two types, and that's an internal disturbance and external disturbance. In internal disturbance, we talked about it. Internal disturbance arises due to the variation in the parametric variation in the plant itself. So external disturbances arise outside the plant. Say that maybe external disturbance will arise from the outside the plant. They will arise outside the plant. Say that disturbance will go as an input to the plant. That disturbance will be going as an input to the plant. They can only controlled by a feedback controller. So what's the external disturbance? As external disturbance, number one point is they will arise outside the plant. Arise outside the plant. When they arise outside the plant, and we can say that say it's an input going to the plant. Say in the input or inputs can be number of disturbances going to the plant. And so what is an external disturbance? External disturbance will arise from the outside. It will not be generated inside the plant. So when that disturbance will come from the outside the plant, it will act as an input from wherever maybe we have a starting of the plant, and then we have the in between instrumentation and piping of the plant. Then we have a control system of the plant. So it can come somewhere in the instrumentation, somewhere in the devices, and that will be acting as an input towards that system, and then it will be going as an input towards the system. And then when we are going to control it, the best way to control this can be only controlled by a very good method that we called a feedback control. So this disturbance can be controlled by a feedback controller. We call it a feedback controller. Now, what is this feedback? We'll talk about this in detail. Feedback means we have an input going to the system. That input processes inside the system. Subsystems, a lot of that will pass through those subsystems, and process will take place. Once that process will take place, then a suitable output will be given. If there is an error between the input and the output, that means what was the reference input? If there is an error between the reference input and the desired output, then a loop will go back to the input so that that difference between an input and output will be compensated until that difference will nullify or reach to the value where it will be minimum. Till that the process of the loop will continue. That's a feedback going from input towards when it is processed input, that will go towards an output as a desired output. If that desired output or the actual output matches with the desired output, what is required in the plant, then it's fine. Otherwise, it will go back as a feedback, see the difference between input and output, actual input and actual output and input, reference input. If there is a difference, then again it will go to the loop, and it will continue to be in the loop unless and until we will overcome that difference, and that difference will be nullified. That will be very low, and we will reach to a point where we are able to get the desired output. That's a feedback controller. We'll talk about this controller more in the detail. Now, when we talk about the external disturbances, just a second. Okay. When we talk about the external disturbances are mostly probabilistic. We talked about the probabilistic. They are mostly probabilistic in nature. But probabilistic means A probability is there. It can occur sometimes. There is no fixed chance that it can occur and it cannot occur. So that's a probabilistic disturbance. But it can also be two types of disturbances are there. It can also be stochastic or deterministic in nature. Both of them can also. Deterministic in few cases, not all the cases, but in few cases we can say that external disturbances may be stochastic and deterministic. Now, what is this deterministic? First of all, if we talk about this deterministic disturbance, deterministic disturbance is that disturbance which can be described exactly in an analytical form. So, disturbance, we say that there will be initial values that may be the variables, or we can write like this. Initial values are variables. In this, there can be initial values which are variables, and those variables which are variables and can be described exactly in analytical form. What is this meaning? That if this disturbance is there, then the notion of the control system can anticipate this type of disturbance, and by knowing its parameters we can know what type of disturbance is, and a suitable corrective action can be taken. In meaning is that we can express this disturbance as what are the parameters of disturbance, how the disturbance has occurred, what need to be compensated, where need to be correction. So all that analytical thorough analysis can be done on it, and a suitable measures to compensate or correct can be done. So this is deterministic is that we exactly know the nature of the disturbance, and we know what are the initial values, what are the parameters. We can specify those parameters, we can analyze those parameters, we can look into those parameters, and we can suggest a suitable corrective or compensatory action in this case. So that's meaning of the deterministic. Now, stochastic is second one disturbance. Stochastic this disturbance is one. It's a type of signals. These are types of the signals which cannot be exactly described or predicted. These type of signals cannot be exactly described or predicted. See, whenever the control system, any of the control system, will be coming to the open loop, closed loop details. You'll know about these things, but it's a bit difficult to understand at this point of time because we have not gone through this configuration of the control systems. A signal will come. See, whenever you design a control system, you design a particular control system based on certain parameters, and you anticipate what are the disturbance that will be coming along it once we put a system in the operation. What are the disturbance we anticipate? So this stochastic disturbance is such disturbance that we cannot describe it, neither in analytical form, neither we can know the nature, but neither we can predict it, and neither a corrective action or a compensatory action is inbuilt in the design of the control system. That's not possible for this type of disturbance. So that is exactly, we cannot determine it, we cannot predict it. That can only be compensated later on once the disturbance will occur. So this was a very important point. The notion you should remember, what does the mean of notion? Means general. Notion means if we have to build something, what are the parameters we will keep in the mind? What are the basic parameters we'll keep in mind? So notion of the control system is by and large, when we talk about the notion of the control system, it's by and large used for notion of the control system if you talk about the what should be the nature, notion means while we design a control system, how a control system should be, uh, how a control system should be built, how a control system should be configured, how a control system should have its configuration. So when we made a control system, it is used, the nature of that or the design of that is made in such a way that it by and large is used for offering, by and large it is used for offering corrective action to probabilistic disturbances. So when you are designing any type of control system, so what should be the nature of the control system, and which type of disturbances we should go after. The nature of the control system, design of the control system parameters should be such that we should offer a very good corrective action to the probabilistic disturbances. That's the first thing. Probabilistic disturbances should have a prime priority, whether it's external or arising internally, that doesn't matter for us, but it should be prime priority for us is to offer a corrective action to the probabilistic disturbance, whether they are arising externally or internally. It doesn't matter for us. Then stochastic, then how the nature of that should be stochastic, disturbances to some extent. That means some extent means to correct, offering a corrective action to some extent, and deterministic disturbance to their full extent, and disturbances to their full extent. Okay. Deterministic disturbances to their full extent can be compensated or corrected during the design of the control system itself. Design of control system itself. So what we have learned from it, if we have to build a control system, what should be objective of the control system? Objective of the control system should be first to offer complete corrective action or a compensatory action to the probability disturbance. Whether those disturbances will occur externally, internally, it doesn't matter. Somewhat it has to provide a compensatory action or a corrective action for stochastic disturbances, but deterministic disturbances, it should offer a very good compensatory action to its full extent it can. So this is the nature. So somebody can ask, sir, why not correctly for the stochastic? See, stochastic disturbances are very hard to determine the nature of them, form of them, and we cannot anticipate them. So once they occur, then and compensatory or corrective action can be taken. Very complex type of disturbances, but they are rare in the power system. We don't get them, in the control system. We don't get them off and on. They are very rare in the in case of control system. So this was something about the disturbances, and that to an external disturbance. Now next is set point. Now, what is a set point? Set point is basically a prescribed, that is a specified input value applied to the loop that indicates the desired condition of the control variable. I have told you control variable is process variable is basically the output of the system. You should always remember them. If we talk about the control variable, we also named it as a process variable, flow rate, extra or control variables, process variable, or we also call it as an output of any control system. So what is set point? It is basically a prescribed input value. It is applied to the loop. I'll talk about the loop again. Applied to the loop that indicates the desired condition of the control variable. Feedback loop, I will be talking more. This loop will come again and again. See, loop, first of all, let me tell you what basically this loop look like. Now, let us say I have a small control system. Okay. Then oh, sorry. Now, this is, let us say this is my input going to any general system I'm taking to general control system. This is a system. Any type of system can be there. This is an output. Now, loop means what? Loop means this is a instrumentation and piping here. Let's say this is a, in case of irrigation system, we'll be talking about those open loop, closed loop system in detail. But for the timing, you remember that let's say this is an input we are giving from the tank, and then we have those linkage, mechanical linkages, ball valve, other things, tank, other systems here, and then we are expecting an output. Now, control variable here is, let us say, a flow rate. Let's say control variable is the level of tank, yeah, height of tank. We have to maintain the height of tank at certain height, certain meters, let's say. Now we will be a prescribed value, we will be telling the control system, we will be inputting, we will be giving as a signal to the control system. A signal will be given to the control system that, let us say, this is your prescribed value, that you have to be within this range, 2.5 meters. This is your prescribed point, that you have to be within this point. So that prescribed value is given to this loop, complete loop, so that it will keep check of this height of the tank, so that it will keep the check of this, at what time my ball valve or what time my linkage mechanism will come into the operation. Because if you are inputting something, it will be tank, then we have a linkage mechanism that can close it. I will show that diagram also, so that there will be no output after that. So what will happen here, that this prescribed input will give an indication to the process variable that this is the value where you have to stop. This is the value which I require. Beyond that, there will be overflow of the tank, or there water can leak, so it has to stop there only. So this is the way set point has to be placed. Set point has to be programmed. So the set point can be, in other words, the set point can be set manually. A human operator can go there and change the settings of the ball valve. It can be set manually, or it can be set by some device, gadget, electronic device is that. Suppose actuator is there, valve is there, electromechanical valve is there, actuator we call it. Actuator will take an 4 to 20 milliamp signal, analog signal, and then at the time it is required to close, it will close the valves, it will close the valve, and it will not allow the water or any other process fluid to go through it. So it can be set by using a device, that can be an electronic device, or it can also be done using what? It can be programmed into the computer. You can use a computer like we are using in the programmed into a computer, like we are using in case of, big process in uh, oil and gas, chemical plants, petrochemical plants. We use lots of a big DCS system, distributed control system, where we program the set point and we put it in the computer, and we monitor all those activities there only, that our process fluid should not go beyond the set point. So these are all things which come under the set point. Now, if I talk at the reservoir system, which we'll be talking in detail in the coming lectures, in water reservoir system, if we talk about the set point, water reservoir system, it's a simple example. Okay, the set point is determined by the position is determined. How it is determined? It is determined by the position at which the float is placed in a rod. So we'll see that diagram, how the float will be looking, how the float will be, when the water level will go high, it will, linkage mechanism will push that float, and water, it will close. Water level will be low, and this float will be going up. आपने देखा वो बॉल वॉल जैसे आपके घर में होता है, तो जब भी आपके पास पानी भर जाता है वो उसको क्लोज कर देता, बॉल नीचे चली जाती, नहीं तो बॉल ऊपर चली जाती. That's called a linkage mechanism, and that's a float also called, बॉल जिसके साथ लगी होती, that's called float. So we'll be talking about this in more detail in the coming lectures, how the linkage mechanism, how it works. So Philhal, for the time being, you have to remember what's the set point. Set point is prescribed input value that will be given to the loop, so that it will provide us the condition of the process variable, that where the process variable at this time stands. Because we have prescribed already the value, we'll see its condition where it stands. It should not go that beyond set point. Otherwise, because we will reach to the output, and then it has to be stopped there only by some mechanism, whether that's a manual mechanism or that's a automatic system. Next point is a feedback control. It's very important, this feedback control definition. Now, feedback control, if we talk about the feedback control is basically an operation. See, I will repeat this diagram here. Okay. Now, feedback control, if we will talking about a feedback control here. Now, this is input. Okay. This is feedback. This is going to the system. We are providing system input. This is the output. We are getting actual output. Then actual output, we have actual output. We'll call it output, that is actual we are getting from the process. And then we have a desired output, what we are expecting to get from the process. These are two different things. Desired is exactly what we require from the system. Output is, actual output is what is we are getting from the system. That means once the system is in operation, what we are getting from the system is the exact output. So that may be some less, some more, but desired output will be different. So feedback system refers to an operation. So from this diagram, I am going to clearly explain this. Just a second. Okay, what the feedback system is. Just a second. Okay, it is what feedback system, it refers first to an operation. It's a type of the operation. What is done in the operation? Shabash. Now that in presence of a disturbance. See, feedback system can be only applicable when there is disturbance. जब तक if your health is okay, everything is fine, you don't need to go to the doctor. Why you should go to the doctor? But once there will be, God forbid, something sickness, then you have to go to the doctor and see what's the problem, and he will give you the appropriate medicine. So once there will be a discrepancy between the desired output and the actual output, then only the feedback system will operate. Otherwise, there is no need, because you are getting the desired output. Why should you operate the feedback system? So feedback control is very important here. It refers to the operation that in presence of, it is very important that in presence of what? In presence of disturbance. So it can be operated only when there is disturbance. If we are getting actual output equal to desired output, no need to operate this. In presence of disturbance, it will do what? It tends to reduce what? It tends to reduce the difference between the output of the system and some reference input. That means actual output and reference input. It will try to get the difference between them, and it will does so on the basis of if the difference exists, and it will does so based on if the difference exists. It's very important that difference should exist, otherwise there is no need of this operation. So what it will do, it will tend to reduce the difference between the output and the reference input. They should be equal. Ideally, they should be equal. There should be no difference between the reference input and the output. So if this is fine, then we need not to operate the feedback control. But if there is difference, so it will tend to reduce that difference in presence of the disturbance. It will tend to reduce the difference between what? Actual output and the reference input. And if the difference will exist. Okay? Here, what will happen? The unpredictable disturbance can be so specified. यहाँ क्या होता है? In control system, only unpredictable, जो predict नहीं किया जाता है, disturbances are so specified. We are specifying those disturbances which cannot be predicted by the control system. Since what will happen, the disturbance which are known to us can be always compensated within. So known disturbances can be done what? If there is a known disturbance can be compensated within the system. Within the system. So this is very important point. Another. So what will happen? Here only the disturbance which we do not predict, which we do not anticipate, are specified. Means we are talking about those disturbances. We are implementing or executing this feedback control system for all those disturbances where we are not anticipating the type of disturbance. What is the type of disturbance? If known disturbances there, like probabilistic disturbances, internal disturbances, scaling of piping, that examples I have given, then we make sure that while we are designing the control system, we already make some arrangements to compensate those type of disturbances. So we are talking about feedback control system for the unpredictable disturbances, which we are not anticipating. In case of industrial automatic system, what will happen? In industrial automated control, any type of control can be there in industry. It is performed how? It is performed by using closed loop system that we'll talk about more in detail. Is performed. जो मैंने अभी बनाया, this is a closed loop system for the time being. This is a closed loop because there's a feedback. This is a feedback here. There is no open loop. Open loop will not have this feedback. The difference between open and closed is feedback. That we'll talk about more in detail. Industrial, when we have any control system in industry that is automated, That means that's an automatic control system. That automatic control system is performed by using what? Closed loop system. This is very important. No open loop system will be used there. Is performed using closed loop system. Closed loop system means all the instrumentation and piping will make a closed loop, starting from a reference input, going through the process and getting the actual output. That means the loop. So what is the loop term means? You'll be wondering what the loop term. Loop term means, the meaning of this is, the you have to clearly understand what loop means. First, in electrical engineering we are also talked about the loop. It is same thing, but here the ingredients or the devices will be different. So loop is derived from the fact that loop means it's based on the fact that once the command signal is given, or it is entered into the input, it will do what? It will travel around the loop. It will travel around that complete loop, and it will continue to do so. It travels around the loop, and it will continue to do so unless and until equilibrium will be restored. Until equilibrium. What is the meaning of equilibrium here? Equilibrium is restored or will be restored. One and the same thing. See here. Let us say a desired output is 26-degree temperature. I want to make the room temperature 26-degree temperature. I am giving an input command. It's passing through a temperature control where the thermostat is the main switch. So I have a furnace here, or I have a heating system here. I have to maintain this temperature. So I will keep on giving the input, and I will see what is the process. If the temperature is below this 26, then heating system will be switched on. If it is below, if it is above, then heating system will be switched off. That will be automatically done by the thermostat, which is a switch, normally open or normally closed switch, which can be done automatically by giving a 4 to 20 milliamp analog signal to it. It can be done by giving a 4 to 20 milliamp analog signal to it. So that will maintain the temperature around 26. If it is above, it will switch off the supply to that furnace. If it is below, it will switch on the supply. So that will continue. So once we are doing it, unless and until that will not happen, that means we have input. Input is exactly 26. That means we need 26 degrees centigrade. We are getting an actual output, say 25. First, we are getting 24. Then again, it will give a signal to the feedback. Your temperature is not correct. So feedback is 24, input is 25. So it will see the difference between 26 and 24. So that two difference will be fed to the error system. This is an error where we will talk about this in more detail. This will differentiate between the actual output, and the input. That means what are the desired output is there. So it will make the difference, and that amount of error it will give to the error system. Here will be some system that can compensate the error. That error system will give a signal to the system that this much of error is there, you need to compensate for it. The controller will compensate for that error, and that will continue to be in a closed loop unless and until this phenomena will continue for a time being, unless and until this equilibrium is restored. That means equilibrium restored means the sense that we have reached nearly appropriately towards the temperature of 26. Once this is restored, then your feedback will start operating. It will start working. It will stop working. Sorry. So that is the meaning of the loop. So once we give a command to it, it will enter the command. It will take the command. That command will travel through the loop, seeing that the difference between the reference input and the actual output is very less. That is equal to the difference is almost nullified difference. That is a zero difference, very small difference, so that we will reach to the point where we can reach to the desired output of the system. That means we are restoring unless and until that loop will operate until we are restoring the equilibrium. That is until we reach to the desired output of the system. That's the meaning of the loop. Now, next is If we talk about more about this feedback control system, what is the basic funda of the feedback control? Basic funda, that is, what are the basic fundamentals behind it? Feedback control system. Basic fundamentals is that error must exist first. First requirement is that error must exist. Without error, you cannot apply. I'm time and again repeating, without having error in the system, you are not going to operate the feedback control system. No feedback control, you are not going to apply. So first condition is first the error has to exist. Then what will happen? Once the error will exist, before some compensatory action can be made. Okay? Basic fundamental is that the basic feedback control is that error must exist before some corrective, to be more precise, corrective action or compensatory action can be made. So you cannot apply the feedback control without having an error. Error must exist. Then a suitable signal will be sent, which will make a corrective action for that error. So error can be developed in the three ways. You should always remember the possibility of error in the automatic control system. Error can exist in the three ways. What are those three ways? First and the foremost is that set point is changed. Now, if you have put a set point for the reservation control system or water reservoir system, set point you have put a set point and that gets changed, that means that will develop an error in the system. Second thing is that when a disturbance occurs, any type of disturbance, that can be external, internal, stochastic, deterministic, or probabilistic, any type of disturbance occurs, that will have an influence on the output of that system, desired output. So error exists there only. Third is if the load demand changes. Now, first you have some load demand, in a sense that power system, you are generating this much of electrical energy, and then all of a sudden there will be a drop in the load. Then the output expected will go down, and then in that case error can also exist in the system. So these 3 points will result to an error, and because of these three uh, situations, we will be enabling or we will be operating the feedback control, so that it will travel through a complete loop, and making sure that there is a very meager distance between actual output and the reference input. Once that difference is nullified, and we reach to a equilibrium point, that means we reach to a point where we will get a desired output. That's the feedback control. So this is all about the feedback control. Now, having said this, let's go to now control system. Again, we'll talk about the control system in more detail. Now you have a good idea of the certain terminologies. Now we can define the control system again. Okay. Now, having said that, these terminologies we have explained in a detailed manner. I have explained all those terminologies. So what the control system looks like now. Now, if I talk about the control system now, a control system consists of subsystems that we talked already, subsystems, and it also consists of processes, bracket, plants also. Process will come from the plant itself, or plants which are assembled for what? These all are assembled for for the purpose of what? What is the objective? For the purpose of obtaining a desired output with desired performance. with desired performance when that performance, but we have to provide a suitable input given a specific input. So I have defined a bit control system more in a more elaborative way. But now control system, we already talked about that it consists of subsystems, processes and plants. Okay. All those systems will be assembled together. That means they will be interconnected together. The objective of that is what? To get the desired output, but the performance has to be also good. It's not that desired output means although we are getting the output and then performance has to be good. We are getting a device, we require an output for a particular process, for a batch of a particular process. Suppose we have any food and beverage industry. I need a batch of flour to be packed and to be, to be prepared that flour with other ingredients. Maybe in a time span of 1 hour, I need a 50 packets of the flour from a food industry. Then, although we are getting the desired output, but we anticipate the desired output has to be, we have to get the desired output in a 1 hour, but we are getting that in the 4 5 hours. That means output we are getting, but performance is not there. So we have to get the desired output and suitable performance has to be there. Desired output with desired performance. That means it has to finish the batching within the 2 hours or within the 1 hour, what we require. If it is finishing complete batching and amalgamation of the ingredients into the flour or into the whatever you are making a particular uh, food packet. So those performance, we need desired output, quality of the output also fine, that is fine, but then desired performance, it has to finish in a particular time. So it cannot be without a performance. So that's what is a performance. But we have to provide a suitable input. Once we give an input to this, then only we will get an output. So here I'll be drawing a bit diagram more. This is okay. So now here will be input. We also called it stimulus. This input is always, I will just prove that this input is always our desired output. I'll just show you by examples. Or desired output. If not desired output, then I will say desired response. The same thing, response. Stimulus and response is there. Okay. Then we have a complete control system. And then we'll get output. We call this response, actual output, response, or actual response we called it. I was just talking about these things. So I have input, I have actual response, I have desired response. These are three very important things in a control system. What we expect, what we are exactly getting, what is an input, and how we can reach to the equilibrium. Okay. Let me take an example one. I have just defined that example. No, let's go by example one for the control system. Now, control of a room temperature. Now, I need to make a control of a room temperature. I'm not going for the closed loop or open loop. For the time being, I am just explaining a simple control systems. Once I will explain an open loop, closed loop configurations, then we can come to the complex from the reservoir system, irrigation system to the missile system or any other system. We can explain those system or autopilot, how the autopilot when we take off from the this aeroplane, then what is the ingredients that will happen in the autopilot. So then we will move to the complex examples. For the time being, we have a very simple example. I need to control of a room temperature. Okay, what I am going to control, it's not here in our Kashmir. We are lucky that weather is always friendly. We have a friendly weather in Kashmir. Maybe 35 is the maximum we are getting, maybe some 36. But lucky in the winter it's a bit harsh, but not too harsh. But if you go outside, you can see the temperature mercury is rising like anything. Okay, control of a room temperature when I'm talking is achieved. How it is achieved? is achieved by switching on and switching off a power supply to heating appliance. How I'm going to achieve the control of a room temperature? By switching on and switching off, sorry, appliance, this is not applied. Switching on or switching off of a power supply to a heating appliance. Now first, the power supply to the appliance is switched on when the room temperature is felt low. Now if we have room temperature low, now what will have happen? Power supply is switched on. So room temperature is low, power supply definitely will be switched on. So room temperature is high, then power supply will be switched on. So in this way, when the desired temperature is reached, we will stop switching on or switching off the supply. I will explain again. Very simple control system. I have to control the room temperature by switching on or switching off of a power supply, which is power supply is going towards the heating appliance. Now, if my temperature is below that expected value, then what I will do, if room temperature is below, then I will switch on the supply, and supply will go to the heating appliance. Heat will be generated as a rise. There will be temperature rise, and it will continue to rise till we reach our desired output. Similarly, if room temperature is high, I will switch off the supply. It will continue to drop the temperature unless we reach to the desired temperature. This is a very simple way of what? This is a simple way of controlling a room temperature. A very simple example, nothing in this case. Now, to be more precise, let me have another good example. Now, another example is, consider an elevator. You have seen elevator in lots of, you can see elevators in hospitals, you can see elevators in the multi-story buildings, in big hotels. You can see them from moving from one, or big apartments, one floor to another floor. These what you call it, elevators will take you from this one floor to the another floor. Let's consider an elevator. Let's have an elevator. Consider an elevator when the fourth floor button is pressed on the first floor. So what you do when you go somewhere, if you have to go to the fourth floor, you will go inside the elevator, press the button of fourth floor in the first floor itself, because you will be starting from the first floor. Okay. That means when the fourth floor button is pressed, when you are in the first floor and you are pressing the fourth floor button, the elevator will do what? Elevator will rise to fourth floor. Very simple. Elevator will rise to fourth floor because you are pressing a button on the first floor and telling him that I want to go to the first floor, and elevator will rise to the fourth floor with a what? With a particular speed, with a speed and floor leveling accuracy. Just a second, I don't know, sometimes leveling accuracy, just I want to stop. Okay, flow with what? When you press the button, it will reach to the fourth floor, but that will depend on speed and the floor leveling accuracy that will be designed for the passenger comfort. So what you are going to do as an example of the control system, a basic control system, again, this is not a big complex type of control system. Now I have gone to the first floor. I want to go to the fourth floor. I will go inside the elevator. I will press the button of fourth floor on the first floor, but that button designer or the control system engineer will have designed a speed and the floor leveling accuracy that will depend on the passenger's comfort. Now, push of the fourth floor button is what? Push of the fourth floor button is input. So when we are giving a push of fourth floor button, so this is nothing but input that represents our desired output. Input representing desired output. यही है ना, इनपुट तो हम दे रहे हैं हाथ से, क्या बोल रहे हैं उसको इनपुट, भाई चौथे पे चला जा, मगर वही तो हमें जाना है जो हम इनपुट दे रहे हैं. In other words, output, desired output भी तो वही है. The output is same thing, that we have to go to the floor number 4. That is what we are expecting. Giving input on the first floor, that you go to the fourth floor, pressing a button is our desired output. So I will show the diagram for this. It will be shown as a step function. जैसे हमने step function पढ़ा था network में, it will be shown as a step function. Now we can represent this as a shown as step function that I will show you. Okay. Performance of the elevator can be seen. Let us see from this curve. So I will draw the curve here. So you can, oh, sorry. You can see the performance of the elevator. Okay. Okay, let us say this is our expected output. That means this is the floor number 4. 4. That means elevator, यहाँ से मैं क्या कर रहा हूँ? This is an elevator location. This is an elevator location here. And this is my input command. That is also my input command. Fourth floor. And this is a time, that how much time it is going to. This is a time, from this time it will rise up. So time versus the elevator floor, number of floors, elevator location, that means floors, where the number of floors will be there. Okay. So now you can see there will be two portions. First will be transient, as we have studied earlier. Transient will be like this, and then we will reach to a value called a steady state value. So this portion, I already talked this in the network detail में, मैंने इसलिए बताया वहां पे ताकि आपको कंट्रोल सिस्टम में कोई प्रॉब्लम ना हो. This, if we talk about this, if we talk about this here up to here, this is nothing but this is a transient response. That means output is not settling at one place. It is still moving above to the fourth floor. This is a transient response. Then once it settles down, so once it will settle down at a particular location, that means near to that fourth floor, sorry, yes. So this, we will call this as an steady state response. So this is a steady state response now. This response at that elevator is now steady state. Now the elevator has moved to the fourth. Now I'm drawing a more distance between the expected and this one, but just to show you that for the sake of the error I am showing, because I have talked about the error. Okay. So if you talk about the difference here and the difference here, this is nothing but your steady state error. Actually, it has to be very low. There has to be error. Error के बगैर कोई चीज होता नहीं है. Steady state error. Okay. So this is the way we are showing the elevator is moving from the first floor and it has reached to the fourth floor with a speed and floor leveling accuracy as per the design of this elevator. So there will be some error. So what are the factors now? Two major performances are apparent. Okay. There are two major performances. We can see here two major apparently we can see two major performances. That means we can see clearly. Number one is a transient response, and number two is a steady state response. Okay, add a page here. It's a steady state response and a transient response. Now let us throw some light on these responses. So in our example, what example I have taken? In our example, passenger comfort, there's two things, passenger comfort and passenger patience. Yeah, roll number 6. Yeah, roll number 9.
Yes, sir.
Passenger comfort and passenger patience depend on what? Which type of performance?
ये passenger patience मतलब डिपेंड करेगा ट्रांजिएंट पीरियड जितना काम होगा
टेल मी द नेम, मैं बाद में बताऊंगा इसको. आप मुझे किस परफॉर्मेंस, ट्रांजिएंट या स्टडी स्टेट में आएगा, किस में आएगा?
अरे दोनों आएंगे
नहीं, it will be dependent upon passenger comfort and passenger patience are dependent upon what? Are dependent upon transient response. ठीक है? You are listening to the lecture या तुम सोए हुए हो?
सर मैंने भी यही बोला.
Okay, fine, no problem. Now what will happen? I'm talking that this two performance, there's a two performance, transient and steady state. Now, if I am designing it for the passenger comfort and passenger patience, they will be entirely dependent on the transient response. How? Now, if the response is too fast, what will happen? If the response is too fast, what will happen? Passenger comfort will be sacrificed. Passenger comfort will be sacrificed. They will not get a proper response. Is too fast. दिल जैसा घबरा जाता है आदमी को जो डरते हैं. So तेज स्पीड होगी, अच्छा नहीं लगता है. The passenger comfort will be sacrificed in this case. Just a second. Sacrificed. SEC. Okay. Then if it is too slow, then problem is if response is too slow, then what will happen? Passenger patience will be sacrificed. आहिस्ता आहिस्ता चलेगा, खट 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 ऐसा चलता है ना. कभी कभी आपने तो नहीं देखी, हमारे टाइम में हमने गाड़ियां देखी हैं श्रीनगर में, वो आती थी निशात से, आराम से चलती थी. पहले तो हमने कुछ ऑटो भी देखे हैं, हमने तो बहुत सारी चीजें देखी. आपने तो नई जनरेशन ने कुछ देखा ही नहीं है. तो उसमें आराम से चलते थे वो अपने मजे से, लाल चौक वहां से आगे. तो दैट वाज टेकिंग टू मच ऑफ हेल लॉट ऑफ टाइम. तो in that case also passenger patience was sacrificed. Passenger patience, if the elevator is too slow, speed is very slow, so passenger patience definitely will be, passengers patience will be sacrificed in this case. So designer has to be very good in a designing of a control system. Neither he has to sacrifice the passenger comfort, neither he nor he has to sacrifice the passenger patience. Both in between, blunt between the two, he has to find some way. Now, second is steady state. When it will reach steady state response, so there will be a steady state error, because you cannot have a system that's a perfectly man-made system, cannot be perfectly 100% perfect, an ideal system, no way. There has to be error. So steady state error is another. We'll finish that and then finish the lecture. See, we cannot leave it here. Thoda sa hai. Is another important performance specification. ठीक है? Why? Since the passenger's safety and convenience is also important. Passenger, क्या पैसेंजर की सेफ्टी भी है और कन्वीनियंस से कैसे, एंड कन्वीनियंस would be sacrificed if elevator will not land properly. क्या बात है, अगर आपके पास एरर ज्यादा है, जितना जितना एरर आपके पास बढ़ता जाएगा डिजायर्ड आउटपुट से और एक्चुअल आउटपुट से, जब आप लैंड कर रहे हैं वहां पे चौथे फ्लोर पे, अगर ये एकदम से आपको ऊपर चला जा रहा है, नीचे चला जा रहा है, या पहले ही स्टॉप हो रहा है, तो उसमें क्या है, पैसेंजर की सेफ्टी नहीं रहेगी क्योंकि आप बीच में लटकते रहोगे, और कन्वीनियंस भी नहीं होगी, वो कन्वीनियंस क्योंकि आपको जाना है फिर नीचे, आपको आगे, देन यू हैव टू, the elevator will open and then you have to reach the fourth floor. So landing of this is also very important, and safety of passengers is also important in the sense that there should be a minimal steady state error. Steady state error should be minimal. If the error will be minimum, then a passenger can land safely on the fourth floor, and it will be convenient for him to reach to the fourth floor. If error is more, then it will be very discomfort for him also. So two performance factors are very important in this example of a control system. Number one is steady state response and transient response. So the performance factors will depend for the first one, transient response, two, comfort and passenger patience will be determined, and second, convenience and landing of the this elevator will also be very important in second series. I think that's all for today lecture. Anybody? Yes, I will stop the recording first and then